This is another video of me prattling on and on about firearms and standards. Standards are great. Everybody has one of their very own. The Wikipedia page on 5mm caliber, otherwise known as I really, really wish I could drive a spike in my skull to make it go away. Yes, I'm editing it. And then I come into the quandary I'm going to discuss in this video. Warning, any standard, when translated to any other standard, will have errors. This is the reason that you may be required in-house to always use metric or imperial because that's the standard. And then you get the yeah buts. No, you don't understand. This is a long, drawn-out discussion about accuracy, consistency, and precision, and none of those three have to match. You can have everything consistent but not be precise, which means they can't really be consistent, but they are. They're consistently within spec, which means they're not consistent. You can make everything absolutely perfect within a certain specification and have it not work. On the Wiki cartridges page for 5mm, there are two Wiki cartridges that are 222 bullet diameter. That may or may not be true. I'm already going through and trying to find out, number one, is it correct compared to the Wikipedia page about each cartridge? This is a lookup table of all the cartridges, by the way. Some of them don't match. In fact, I'm going to be doing edits for that. But should I? Is there an original source, or is the standard in any way precise? There are only two cartridges, the CB and BB cap rimfire cartridge, the little dinky ones that are barely a bullet of any kind, that are rated as .222 inches in caliber, or 22.2 caliber. Let's continue. 223, you might think would include the 223, 5.56, and all that. There's only three cartridges. A long and short rimfire, the 22 long and 22 short rimfire. They're not 22 long rifle, by the way. And a revolver. There is no, according to it, rifle cartridge that really is 223. 224 includes 21 Wikipedia cartridge entries in their lookup table. By the way, I'm going through and adding in the missing entries so you can sort that correctly. Because you have to be able to sort it not by millimeters and not by inches, but both, and have them consistently give correct changes. They do not. And it was dependent on adding in the last two zeros after 5 for 5mm. So if you put in 5mm, it gives you 20 caliber, but if you put in 5.00mm, which should be the same, it isn't. It gives you the different answer, because Wikipedia's conversion utility made a mistake of rounding up to the next highest number of significant digits. If it's 5mm, you only need 2 digits. No, that's not true. You have to have an implied 3-digit precision if the end result is going to be 3 digits. This is a common error in programming that Wikipedia has made for its basic metric to imperial conversion utility for the entire time it's been up. That's an error that was addressed a long time ago in web standards and software standards, literally 2 decades ago. You must stretch the definition out, even if it comes up with numbers that seem artificially escalated to insane precision that can't happen. You have to include it so that when you do a sort of diameters for bullets or length for toothpicks, it shows accurately. It did not. Automated processes will fail automatically. But anyway, all the cartridges in the 224, most of them, range, especially 223, 5.56, and 22 Magnum and 22 long rifle, confirming, at least at the time, which may change because I may have to correct my own screw-up here, the 22 Magnum and 22 long rifle and 223 cartridges, Remington, and 5.56 NATO can use the same barrel, or can they? And then 225, because I've decided to look it up, there's 7 Wiki cartridges. Now let's read that back in reverse order. Or more accurately, let's start with 5.56 and 5.55. 5.55 is, I'm going to say, caliber. Caliber refers to, in whole numbers, hundredths of an inch. We're dealing with thousandths of an inch and 10,000ths of an inch. So let's do this up. If we do 5.55, not 5.56, but 5.55, we end up with 21.85 caliber. 5.56 is 21.89 caliber. 5.57 is 21.93 caliber, not quite 22, and 5.58 is 21.985 caliber, and we do 5.588 is actually finally 22 caliber on the knot. Or is it? The precision, or pissy-ass fiddle factor you can get out of using whole millimeters and 1/100ths of a millimeter, obviously a millimeter is smaller than an inch by a massive amount, is so much better on paper than using 0.2185. But that's down to 1/10,000th of an inch if we do this pedantic number of 4 significant digits. If the digit in front of the 2 is a 0, it's not significant. We're doing 4-digit precision. If we're doing the numbers rounded off, no. Yeah, rounded off, we're still doing 4 digits precision down to 1/10,000th of an inch. But we're doing to 1/100th of a millimeter. Okay, let's get this done really quickly. If you have bullets down to 1/1000th of an inch, and do that as your specification for doing the incrementation on your measurements for a CNC machine, a lathe, a mill, whatever. What are we talking about that? Okay, 1/10,000th of an inch in imperial conversion factors, all these kind of things. But let's do this really quickly. 1/1000th of an inch works out to about 1/4 of a millimeter. That's 0.025 millimeters. It's actually a little more than that. Now, if we have 5.567, we have the same level of precision being mentioned here as we do, oh gee, that works out to 4 digits of precision again. And again, those are significant digits. If I tell you that something is 0.5 volts, that's 1 digit of precision. If I say it's 0.00005 volts, it's 1 digit of precision. We're only mentioning literally 1 digit out of potential much finer grain. But once we get to 1, picovolt, I don't think we need to worry about the trailing digits anymore, right? Except if you're doing that as a conversion from energy potential across a membrane involving variations in hydrogen content inside of a battery, suddenly 1 picovolt of change needs to have higher precision because you're measuring really atom by atom changes. The Remington, 35 Remington, 0.349 bore diameter, 0.357, like 357 Magnum, groove diameter. That's a 0.008 or 0.008 of a difference between them, working out to a groove depth of 0.004. That might tweak some of your ears. The 223 Remington, aka 5.56, aka the AR-15 America cartridge, if cut properly according to various sources, or standard, or according to the usage in the United States at the Remington ammunition factory for the barrels they use for the standard, or not, depending on what year and whether it was a Tuesday, the bore diameter is 0.219, not 22. The groove diameter is 224. The difference is 0.005 thousandths, which works out to 0.0025 groove depth instead of 0.004. Now, if you check it between the 35 Remington, I picked this one randomly, you get a change in the bore of 62.75%, and the groove depth changes at 62.5%. It's so close you would think, is the groove depth based on the diameter of the bullet? Now, for those of you who are uninitiated, when a bullet is fired out of a gun, whether it's a short, stubby one or a long, skinny one, determines how much you need to spin it on axis. If it's kind of, basically it's the same length that is wide, it can tumble and probably aerodynamically hit the same spot every time, but it increases the probability of hitting a very narrow range of spots on the target if you spin stabilize it. That's why we use, in guns, rifling. That's the only reason. And the longer the bullet, the more the rifling gets to be important, because if the bullet comes out without any spin stabilization, it's as long and skinny as my finger is on ratio, comes out of the barrel, it can do this. And that means it will start gliding up and then gliding down. You can even see this in some high-speed video recordings of unstabilized bullets. So spin stabilizing it makes it go straight, except that's with reference to which way it's fired from. As it goes further, it will start falling. Now, it will do this as it falls rather than this as it falls. Or more accurately, as it falls, it will tend to gyroscopically stabilize along the axis it was fired at, and over extreme distances with curvature of the Earth, with reference to gravity, it'll be tilting upward. And yeah, aerodynamically, that's advantageous. It forces it to try to stay on target more. It has no negative outcomes unless you do over 8 miles distance, which, unless you're doing artillery shells, it's not relevant, and they're spin stabilized as well. They are. I found that out. I didn't know long-distance 20-mile shots are done that way. Okay, I mean, I looked it up just real quick. It's not really hard to look up. So is it based on percentage or not? Well, what if you're only rotating it slightly? Again, what if it's a short, stubby bullet that doesn't need much rotation? Do you need deep rifling just to get it to spin a little bit? Or do you need more depth to the rifling if you're making it abruptly change rapidly? What's rapidly? Okay, how fast is the bullet going? How much barrel does it have to go through? And how much rifling do you have available? Short and sweet, not quite. The thickness or depth of the groove is based on how strong the material is and how fast or how short of a duration of time you have to spin this mass of material. If it's a really big bullet, you're going to have to spin it a little slower in time, not depth or anything. It's how long it takes in order for that bullet to be able to get to where it's rotating at all. Otherwise, you're just going to shear off the outside of the bullet and just make a bunch of powder come out. As evidenced by people making really short barrels have to do really high spin rates for pistols that were high bore diameter. They couldn't do it. They had to do a slower twist rate. Or they had to do really deep rifling. But when they did that, it caused more disruption to the surface of the bullet. There are hundreds of variability things here. Then you get to the 30 caliber rifle barrels that do the same thing, and they all have the same groove depth, 0.004 or 4 thousandths at 30 caliber. Is 4 thousandths depth a general standard for groove depth, or is it based on caliber percentage? Yes. It's dependent on both or neither because of something simple. Does it work? That's it. This is something I and a few other people in Portland called the does it make noise category. If you're trying to make a full go, no-go test of a sound system, the only thing you care is if you feed a signal in to all the speakers, did it make noise? Well, there might be some technical yes or no, is the fucking speaker working? No. Unplug it and take it off stage, plug another speaker in. Does that work? Yeah. Then it's a speaker. Does it make noise? You start yelling that because it's easier to hear yes or no, go, no, go. You just yell, does it make noise? When you yell that in a noisy stage testing amps. Bullets that are 0.01 thousandths to 2 thousandths oversighted for a stated caliber can stabilize better and more accurately than ones that aren't. Do you measure a barrel's caliber based on its land-to-land, groove-to-groove, or the land-to-groove depth? Yes. Again, it's based on what worked. You don't care about anything else. You can have a gun that has a smooth bore at the opening, which is where the chamber is, and have it taper down to the wrong bore diameter. As long as the bullet will conform to it, it's great. If you have a steel core bullet with a copper jacketing, you might not want to do that. Most SAMI standard American caliber designations are groove-to-groove, and European Union ones and older ones were based on the bore diameter because that way they would have the same caliber statement for smooth and rifled bores. Microgroove barrels have shallower grooves, half depth by definition, but they have more of them so they have the same amount of surface area between each of them, acting as little fingers forcing the bullet to spin. The RPM value of 33,000 or 333,000 RPM, depending on what barrel you're doing, out of a standard 223-556 AR-15 is important. This means in half a millisecond it has to spin with a 1 7-inch twist out of a barrel if it's a rifle used by NATO. The imperial system versus metric system shows, if you look up the numbers, that using the metric system is higher precision. But the fact that we can do the slop factor is the reason we have the imperial system with thousandths of an inch and not giving a damn if we even have the right bullet or even call it the right bullet type. Precision versus accuracy versus consistency. It's what The effect is not what we want it to be that's important.